Welcome to Mind to Your Learning, where we make GCSE learning and revision simple. Algebra can sometimes feel like a completely different language because it uses letters, symbols, brackets, and powers. But once you understand what each part means, algebra becomes much easier to read. In this lesson, we'll learn how letters and symbols communicate mathematical ideas clearly and efficiently. Before we begin, remember to like this video, subscribe to Mind to Your Learning, and follow along carefully. By the end of this lesson, you should be able to represent unknown values using variables. You will learn the correct algebraic conventions for multiplication and division. You will be able to distinguish between coefficients, variables, and terms. Finally, you will practice interpreting more complex expressions, including expressions with brackets. These skills are important because they help you understand what algebraic expressions are actually saying. Let's begin with the key vocabulary. A variable is a letter that represents a value that can change or is unknown. A coefficient is the number multiplying a variable. For example, in 5x, the coefficient is 5. A term is a single mathematical part, such as a number, a variable, or numbers and variables multiplied together. An expression is a collection of terms and operators without an equal sign. For example, 3x plus 5 is an expression because it contains terms, but does not have an equal sign. Imagine you have a sealed box of chocolates. You do not know how many chocolates are inside, so you call that unknown number n. The letter n is acting as a placeholder for a number we do not know yet. Now imagine you have 3 identical boxes. That means you have 3 lots of n. In algebra, we do not need to write a multiplication sign. We simply write 3n. So 3n means 3 times n. The key idea is that letters in algebra are simply placeholders for numbers. In algebra, we avoid using the multiplication sign because it can look too much like the letter x. Instead, we write terms next to each other. For example, 3 times a becomes 3a. A times b becomes ab. And y plus y plus y becomes 3y. This is a shorthand system. It makes algebra quicker to write and easier to read once you understand the conventions. So, when numbers and letters are written next to each other, multiplication is happening. Let's check your understanding. You need to match each word to its correct meaning. The words are variable, expression, coefficient, term. The definitions are a mathematical phrase like 3x plus 5, a group of numbers and letters like 4xy. The letter represents the unknown, the number part that multiplies the letter. Pause the video and try matching them before we check the answers. Let's check the answers. A variable is the letter representing the unknown. An expression is a mathematical phrase like 3x plus 5. A coefficient is the number part that multiplies the letter. A term is a group of numbers and letters, such as 4xy. These definitions are the foundation of reading algebra accurately. Just as we usually remove the multiplication sign in algebra, we also avoid using the division symbol. Instead, division is usually written as a fraction. For example, x divided by 4 is written as x over 4. This makes algebraic expressions easier to read, especially when they become more complicated. Fractions also make it easier to simplify and rearrange expressions later on. So, when you see x over 4, read it as x divided by 4. Now, let's look at powers and indices. When we multiply a variable by itself, we use an index, also called a power. For example, a times a is written as a squared. X times x times x is written as x cubed. If we have a times b, we write this as a squared b. The small number only applies to the letter it is sitting on. So in a squared b, only the a is squared. The b is not squared. Let's apply those rules. How would you correctly write y times 7 in algebraic notation? Is it number 1, y squared 7, number 2, 7y squared, number 3, y 7y, number 4, 7y. Pause the video and think carefully. Remember, we usually write the number first, then the letters, and we use powers for repeated variables. The correct answer is 7y squared. Here's why. Y times y is y squared. Then we multiply by 7. In algebraic notation, we usually write the coefficient first, so the answer is 7y squared. This is clearer and more conventional than writing y squared 7 or 7yy. Now, let's look at brackets. Brackets group parts of an expression together. Anything outside the bracket multiplies. Everything inside the bracket. For example, 3 bracket x plus 2 bracket means 3 lots of the whole group x plus 2. This is different from 3x plus 2. In 3x plus 2, only the x is multiplied by 3, and then 2 is added afterwards. But in 3 bracket x plus 2 bracket, the 3 multiplies both the x and the 2. So brackets can completely change the meaning of an expression. Algebra follows the same BIDMAS rules that you already know from arithmetic. BIDMAS tells us the order of operations. Brackets come first, then indices, then division and multiplication, then addition and subtraction. For example, in bracket x plus 3 bracket squared, we must deal with the bracket first. That means we add 3 to x before squaring the result. But in 5x squared, we square the x first, then multiply by 5. The order of operations changes how we read the expression. Let's check a common misconception. The statement says 2a plus 3 and 2 bracket. A plus 3 bracket mean exactly the same thing. Is that true or false? Pause the video and think carefully. Ask yourself in each expression, what is the 2 multiplying? The statement is false. 2a plus 3 means 2 times a, then add 3. But 2 bracket, a plus 3 bracket means 2 times the whole bracket. That means the 2 multiplies both the a and the 3. So 2 bracket a plus 3 bracket is the same as 2a plus 6. That is not the same as 2a plus 3. The correct explanation is, in the second expression, the 2 multiplies both the a and the 3, whereas in the first expression, it only multiplies a. Brackets are not decorative. They change the mathematical meaning. This is why it is so important to read brackets carefully in algebra. Now let's try a complexity challenge. Rank these expressions from simplest to most complex. The expressions are 4x, x, 4x minus 5, 3 bracket, 4x minus 5 bracket. Pause the video and think about which expression has the fewest terms and operations and which has the most. The correct order from simplest to most complex is x, then 4x, then 4x minus 5, then 3 bracket 4x minus 5 bracket. X is the simplest because it is just one variable. 4x includes multiplication. 4x minus 5 includes multiplication and subtraction. 3 bracket 4x minus 5 bracket is the most complex because it includes multiplication, subtraction, and brackets. Let's finish with a final reflection. Why do you think mathematicians created these shorthand rules instead of just writing everything out in words or using standard arithmetic symbols? Pause the video and think about your answer. Consider why algebra needs to be clear, efficient, and understood by people in different places. You might have said that algebraic shorthand helps prevent confusion between the letter x and the multiplication sign. It also makes mathematical writing shorter and more efficient. Instead of writing long sentences, we can express an idea quickly with symbols. These rules also make it easier to spot patterns and manipulate equations. Finally, algebra creates a universal language that mathematicians, scientists, engineers, and students can use across different countries. You should now understand how variables, coefficients, terms, expressions, brackets, division, and powers are used to communicate mathematical ideas. Remember, algebra is a language. Once you understand the rules, the symbols become much easier to read. If this lesson helped, please like the video, subscribe to Mind Tier Learning, and watch the next GCSE Maths lesson to keep building your confidence.